math, there are opposites, such as addition and subtraction, division and multiplication. Logs is a way to undo exponentials. They are the complete opposite of them. Let's look out for the rules. I'm talking about logs. Let's ask the tree for the rules, the father of logs. Rule number 1. This is the way logs are written. Rule number 2. When logs are being added, they can be combined and multiplied within the log. Rule number 3. When being subtracted, they can be combined into division in one equation. Rule number 4. If you have a log to an exponent, that exponent can be moved to the front, as seen here. Rule number 5. When dealing with the log with a base of a bigger number, or bigger, smaller number, it doesn't matter, they can be rewritten with whatever base you so desire into this equation. Rule number 3. When having a log with the same number in this part, and the same base, it just equals x because the logs cancel out. Rule number 7. When taking a base of a log, that log becomes the number it is. And of course, there's a special case with natural logs, which equal log e. And the base is always e for those natural logs. Now, the tree also gives us a couple tips. When taking the same base of a number, the base of the same number, it is always equal to 1. When taking the log of 1, it is always 0. There's no way to take logs of negative numbers, so it is always undefined. There's no way of taking a log of a 0, so it is also always undefined. And if the base is less than a number, your answer is always going to be greater than 1, and vice versa. So if the base is greater than the number, the answer is going to be less than 1. So now, let's look at a few examples, simple examples when talking about logs. Our first example is a true statement. 10 squared equals 100. Now let's rewrite that in log form. So in looking at our first rule, it could be seen that logs are rewritten this way. 10 would be the base. 100 would be in the parentheses. And this would equal 2, obviously. Because when dealing with logs, what would the exponent of this be to equal this? So 10 squared equals 100. Next example deals with the rule dealing with addition and multiplication. When having logs with the same bases, they can be combined into one equation. Seven times 5 is 35, and that's what you get. Our third rule, pick down, is dealing with subtraction and division. When having the same base, logs can be rewritten into one equation as log 10 over 5, which, when simplified, equals 2. Next, our next rule is rewriting with exponents. When dealing with exponents within the equation, it can be rewritten in front of the log. So this simply just becomes 4 log of x. And now, our hardest example for this problem, when having this together, you can't combine them because the bases are different. So, you pick the simpler base, and using our rule, rewrite this as log 5 of 3 divided by log 5 of 25. So now, with that, this equals 2, because 5 squared equals 25. So this can be rewritten as 2. Now, you can combine both of these with the same denominator. So this becomes 2 log over 2. And now seeing that they have the same base, they can be combined. But first, going back to another rule that deals with this one, this 2 can be rewritten up here. So this is where we left off with our last example. Now, what to do? Looking at this, we can see that they can be combined. So this obviously equals 4 log 5 of 4 times 3, 12, over 2. Now, normally, most logs can't be done by hand. So, take out your handy dandy calculator and finish this problem off. Now let's go back to our handy dandy logs to find more examples. We have a problem. So now, using this wonderful example that our logs provided us, we can hone our skills and train in the beautiful works of logs. So now we have this wonderful example with 2 different logs and in 2 different bases. What do? What I like to do first is make all the bases the same. So using one of our rules, we can make this to log 2 of x to the 3rd over log 2 of 4. This is one of our simple rules that we had in the beginning. I'll continue to write out the problem. Bring everything down. So now all the logs are in the same base. What do? This is equal to 2. Knowing 2 squared is 4, there's your answer. That's how you do a log. Now we have this nasty denominator. What do we like to do? Cancel them out. So multiply everything by 2. Log 2 of x to the 3rd minus log 2 log 2x equals 4. It's getting easier and easier as we go along. Using another one of our rules, we like to bring this over here. So now we are left with log 2 of x to the 3rd minus log 2 of x squared equaling 4. Now, combining these together using one of our other rules, log 2 of x third over x squared equals 4. We're almost done here. Using basic algebra skills, we know that x to the 3rd divided by x squared simply becomes x to the 4th. Now, another one of our rules is taking a base of both of the numbers. This cancels out, simply leaving x. And 2 to the 4th is 16. And here we have our simple answer. So I know how hard logs are, so let's ask for another example. What is this? Another beautiful example that we can use. So now, yet again, what do? Base of 9 and base of 3. Let's make this a base of 3. So 3 x third log 3 of 9. Bring everything over again. Yet again, this equals 2. Oh, how lucky are we? Now, let's cancel out that 2. Make everything nice and neat. That's 2 3 x 4. Another rule. Let's bring this 2 up and over. This 2x squared equals 4. So now we're looking at this equation. Let's combine them. Log 3 of x to the 3rd over 2x squared equals 4. This log 3 of x over 2, because x to the 3rd divided by x squared becomes x, and 2 stays in the denominator, equals 4. Now, what do? Another one of our rules. Bring the 3 over here. What you do to one side, you must do to the other. This cancels out. X squared equals 81. Get that 2 out of there. Multiply this by 2. X equals whatever 81 times 2 is. And that's your answer. So now I hope, after this quick and simple lesson, logs have become easier for you. Using my video, they should get you a nice, easy 100 on your next quiz. Thanks for watching.